Okay. Hello, everyone. This is Debarshi. I'm a faculty member at the HSS department, Indian Institute of Technology, Guwahati. So this live session is for this course called Mathematics for Economics Part 1, which is being offered to online registered students on behalf of the NPTEL. So this is a live session where you can ask your questions and queries. And I'll try to address them
For economics
as
part
to the
1,
best of my
which
capacity.
is being
So far, we have had two live sessions before where we covered in the first live session the material up to week 7. That was the first live session from week 1 to week 7. And in the second live session, we covered week 8. So the purpose of this particular live session is to address your questions and queries, but you cannot ask every sort of questions because there has to be some order regarding what we can cover in each live session. So do not ask questions which were covered in the previous live sessions. That is up to week 8 we have already covered in the first two live sessions. So if you have any queries regarding week 9 and week 10, these 2 weeks material have been covered after week 8. So from these 2 weeks, that is week 9 and week 10, if you have any questions or queries regarding the material of these 2 weeks, uh, or any queries if you have, you can ask them. I'll also check if you have if you are posing any questions, if you have posed any questions in the discussion forum, so that I can try to address them from the discussion forum. So I can see one question that was asked, um, which is regarding week 8 assignment. Mahika Arun Kumar has asked this question. Sir, could you explain how the answer for it is Q1? This is question number 2 of assignment 8. Since at Q2, marginal revenue is increasing less rapidly compared to the marginal cost. Yes, you are right, but the exact proof is basically the following. Um, so basically, what one is saying that profit is there, right? Let me, if I can go to the question. Yeah, this is the exact question. The revenue and the cost function of a monopolist firm are RQ, R as a function of Q and C as a function of Q respectively. The condition R prime is equal to R prime Q is equal to C prime Q is satisfied at two output levels, Q1 and Q2. So at two output levels, you have a stationary point, right? What is the stationary point? We are talking about the stationary point of the function, the profit function. Because what is profit after all? That basically, that is the idea you have to apply here, that what is profit after all? Profit is revenue minus cost. So if you want to write the profit function, suppose profit function is pi as a function of Q. Q is the quantity of output. So pi Q will be RQ minus CQ, revenue minus cost. Now, when is the profit maximized and when it is minimized, right? In this question, I think the trick is that, and I purposefully made this trick in the question, that we are not asking about the maximization of profit, right? That is the trick. That generally whenever you encounter the problem of a firm, right? The producer, what is the problem that he has? He wants to maximize the profit. So generally we look at that problem and then we get some conditions under which the profit maximization takes place. Here, I purposefully made this a different sort of question to check how alert the students are, right? And here the question is profit of the producer is minimized as at Q is equal to what? It could be Q1. So these are the options. It could be Q1, it could be Q2, it could be 0. And the fourth option is Q1 plus Q2 divided by 4. So out of these four options, which is the correct answer? So, right, it's a multiple choice question. And what is further given that r dash q is equal to c dash q. This condition is satisfied at two output levels, q1 and q2, right? And what is the difference between this q1 and q2? It is further given that at q1, r double dash q is more than c double dash q, right? R double dash q is more than c double dash q at q1, and r double dash q is less than c double dash q at q2. So this is the difference between q1 and q2, right? So there is a similarity between q1 and q2, that at both these output levels, you have r dash q is equal to c dash q. But the difference is that at q1, the second derivative of r is more than the second derivative of c, and at q2, the second derivative of r is less than the second derivative of c. Question is at what output level, that is at what q, the profit is maximized. And the correct answer, as the correct answer is given to the students after the assignment, the last date gets over of submission of the assignment. The correct answer is q1, and that is what this student was asking, that why it is q1. Right? That is the question. The Mahika, that is the name of the student. Mahika was asking that why is it q1. Now the answer is actually very simple. You just have to apply the condition of maximize, in this case minimization of profit, right? You want to minimize pi, which is a function of q, and we know there are this necessary and sufficient conditions, and if you apply those conditions, then you will find that the necessary condition is being satisfied at both q1 and q2, but the sufficient condition of minimization of profit is being satisfied at q1, not at q2. Right? So that is basically the thing that you that we were checking through this question, whether you know the condition for minimization of profit. Right? So basically the minimization of profit condition will give you that the r double dash q is greater than c double dash q. And that is, as we know, in the question it is written that that condition is satisfied at q1, right? So in this question, I wanted to check the alertness of the students, how alert the students are. Usually whenever they see a problem of profit and cost and revenue, they tend to assume that it's a question of profit maximization, and so they can be selecting this second output level, which is q2, thinking that I asked about profit maximization, and profit maximization actually takes place at q2, but the question was not about profit maximization. Okay, so that is that. I do not think there are any other queries in the discussion group. No, I don't think there is any other query. So this query that I just answered, this was not from week 9 or 10. It was from week 8. So I do not want to take questions from week 8 or before. Those were covered. We are now in week 9 and 10. So if you have queries regarding these 2 weeks, and what have been covered in these 2 weeks are basically um, the matters of integration, right? We have talked about integration, the applications of integration in economics. So that is what we talked about. We talked about the fact that both definite and indefinite integrations are used in economics, especially the definite integration. They are useful in many areas of economics. For example, if you want to find out what is the value of capital, the total capital stock, which is a stock kind of concept, um, from some flow information that you have. What is the flow uh, concept in this case? In this case, the flow concept could be investment, right? Which is like the addition to capital. So from investment function, you can get the capital stock at different points of time, right? So that is one, and there are other applications of integration also. We talked about those. So if you have any questions regarding these topics, you can um, pose those questions. So if we're not getting any new questions or queries, then we'll wrap it up sooner rather than later. But before I end, um, I might add what we are going to cover after the 10th week. We have 2 more weeks to go in this course. So in these 2 weeks that are left, we're going to talk about a theme called the difference equations. Now, many of the students who actually enroll in this course um, are from science background. That is, basically they have done mathematics at least till their +2 level, maybe even after that. Now, the mathematics that is taught in +2 level or even after that for general engineering students or BSc, let us suppose, science bachelor students, they deal with what is known as differential equations, where time is a continuous variable. And in differential equations, we try to solve some differential equations where, the rate of change of some variable with respect to time, that is given, and we want to solve those equations in terms of finding the solution of that particular variable, which is not expressed as a function as dx dt term, right? So that will be called the solution of those differential equations. In these two remaining weeks, we are going to talk about something related to time and how variables change with respect to time, similar to differential equations. But here, in these cases, these are difference equations. And why we are using a different term, although we are talking about change of time and how it affects the variables, is because here we are taking time as a discrete unit. So time is not continuous in difference equation. These can be measured in discrete units. Uh, and why we are doing that? Because in economics, those are very useful things to look at, right? When time is a discrete variable. Of course, in economics, differential, when time is a continuous variable, those usages are also there. But when you take time as a discrete unit, that gives you an added advantage, because in reality, if you think about it, in reality, time is measured in discrete units. We talk about 1 month and the next month, right? Or let us say quarters, right? In a financial years, there could be 4 quarters. A quarter, once again, is not a continuous thing. It's a discrete way we are dividing the time. So in reality, when we talk about changes of variables with respect to time, when we deal with data, there we take time as a discrete variable. So if we are indeed taking time as a discrete variable, then how to deal with those cases? So that is why we put a lot of emphasis on difference equations, and these last 2 weeks will be devoted entirely to the analysis of difference equations. We're going to look at how to solve difference equations, how many kinds of difference equations could be there. Obviously, we're not going to deal with all of them, only a handful of difference equations we'll talk about, and how to solve those difference equations through different methods. And of course, the applications in economics, how we can relate those mathematical concepts to the problems of economics. So, right, those applications will also be dealt with in these 2 weeks. So, I think if there are no other questions or queries in this session, then we can wrap it up. CET, is anyone there from the CET? So I don't think anybody is there to ask questions anymore. Okay, thank you so much for joining, if not asking questions. See you next time. Thank you.